Hey everybody, welcome back. This is lesson 27, solving one-step equations. We're going to start as we typically like to do when we're doing something new, is we start with a visual and then we work our way backwards into a more symbolic model, which math relates to. So I'm going to show you this visual using our algebra tiles, and I'm going to provide them for you if you'd like to do the steps with me. I feel like it's good, and it's a good tactile way to learn the math. So we're going to use the algebra tiles. We're going to complete the same work on both sides to keep the equation balanced, and when you're done, you will know what x equals. Again, x is an unknown amount, and it's different every time we solve an equation. And then I will show you how to solve it using just pen and paper. In the traditional way that we will be solving them in class. So I'm just going to pause this. I'm going to go to the algebra tiles. So here are the algebra tiles and the setup that you will be starting with for solving equations. So I have my x plus 3 positives equals 7, which is also positive. So what we're going to be doing is we're going to be adding or subtracting tiles on both sides in order to get x isolated. That's our goal, is once it says x and everything else is on the other side, that's going to be my solution. So x equals what? So I'm going to see, I have these three, and these three are blocking x from being by itself or isolated. So what I'm going to do is I'm going to get rid of the positives by introducing 3 negatives. And if you recall, every time I have a positive and a negative next to each other, what happens is they cancel each other out. So I'm just going to take a line and sketch those out. So those are gone. But because I just introduced 3 negatives on this side of my equation, I have to keep my equation balanced. So I have to introduce 3 on this side. Again, we're trying to keep our equation balanced. Think of it as a balance beam or a balance from science class. So now these 3 sets will be gone. And then what will be left, I'm just going to scoot it down here, is going to be these guys. So I have x equals, looks like positive 4. And that's going to be my solution. X equals 4. Alright, so again, we're going to go back to the worksheet. I'm going to show you how to show this on your handout. Alright, so we're back on our worksheet. So again, remember we took 3 negative tiles here and crossed these guys out, and we took 3 negative tiles here and we crossed these guys out, and what was left was x and 4 positives. So how does this look like when we're doing it algebraically, which is with algebra with symbols? First, I'm going to analyze the problem. I have to start by saying, well, what operations are happening here? Now, if you notice, there's a plus sign. Some of the equations might not have symbols, especially for multiplying. Sometimes for dividing, it might be a fraction bar instead. So we have to be really careful in looking at what kinds of symbols are in my problem. And then we're going to use something called inverse operations, which really just means the opposite operation. Instead of adding, I'm going to subtract. Instead of subtraction, I'm going to add. Instead of multiplying, I'm going to divide. Or instead of division, I'm going to multiply. So in this case, because I see that this is an adding problem, I'm going to do the opposite operation, or the inverse operation, which is subtraction. So watch what I'm going to write on both sides. I'm going to write minus 3 and then minus 3. Again, focus on keeping that equation balanced. So sometimes I've seen people do this. They like to draw a line down the equal sign, because when we talk about keeping it balanced on both sides, the equal sign is that balance point. It's the halfway point. Okay, so now that I've done that, watch what happens. I'm going to draw a bar, kind of like an equal sign bar, right? Plus 3 and minus 3. I have 3 and then I took 3 away, so those crossed out, just like my tiles crossed out. And all that was left was x. And once I took 3 away from the 7, all that was left was 4. And when we're doing multiple steps of solving, we're going to follow PEMDAS but backwards to solve. Your goal, again, is to isolate your variable. You want to get your variable all by itself, because once you have that, x equals something, then you're done. All right. One more step, we're going to show you how to check, and then we're going to do a few more examples together. All right, so some of the examples, what we're going to be doing is we are going to require you to do a check. This is a super simple way to ensure that you know you have the right answer when you're done solving. So we're going to start with 3 steps. It's rewrite, replace, and redo. That's the simple, so rewrite, we're going to rewrite the original problem that we started with. We're going to replace our variable with our answer. So now, according to our solution, x is 4. So I'm going to put replace 4 for the variable x. And my last step is redo. I'm going to redo the math in my calculator. Any math I can do, I'll put the whole thing in my calculator. And guess what? I get 7. And as long as these answers match each other, then you know your answer is right. Again, use your calculator to check the work. All right, a few more questions together, and we'll move on. Okay, so we're on the back. As you see, I've already put Algebra Tiles in on the left side. They are also available to you on your Algebra Tiles Google Slides, so you can manipulate them as you'd like. I'm going to draw them in and show you kind of how we're going to go from here. I'm going to kind of bounce back and forth from the work to the Algebra Tiles. So if you recall, when I look at an equation, my first step is to evaluate and look at what kinds of operations are here. Since this is an adding problem, I know I'm going to do the opposite of that. So instead of adding, I will be subtracting. That way I will get rid of the 8 algebra tiles on this side and leaving my x isolated. Again, my goal is to get this x all by itself. So I have to get rid of 8 algebra tiles. But if I get rid of 8 here, then my equation will be unbalanced. So I need to get rid of 8 on this side as well. So algebraically, that looks like this. I'm going to subtract 8, again, keeping my equation, right, here's my line, balanced. The plus 8 and the minus 8 will cancel each other out, right? 8 minus 8 is 0. And I'm left with x equals 16 minus 8. As you see, there are 8 algebra tiles, and those are positive. Okay, second question. This time I have a subtraction problem. So I'm going to need to do the opposite. When I see subtraction, I have to undo it by doing addition. So I'm going to add 2 tiles on both sides. Remember, when I add 2, I'm adding 2, I should draw it in yellow, sorry. When I add 2 yellow tiles here, remember a positive tile and a negative tile are going to cancel each other out. So here's my 2 positives, they will cancel out these negatives, but I also have to draw 2 positives on this side. So my final answer, once I'm done drawing, my negative 2 and my positive 2 will cancel each other out, and I'm left with 5 positives on the right side. Okay, very similar situation with this question. Again, I'm subtracting 5, so to undo that I need to add 5 on both sides. So I have to add 5, instead of drawing them, I'm just going to write plus 5. On this side again, we'll cancel out all of these negatives, but then I also have to do plus 5 on this side. So again, keeping my equation balanced, my focus is getting x isolated, keeping my 2 sides balanced, so I have to do the same operation on both sides. Before I cross out, I do have to make sure that these actually cross out. A negative 5 and a positive 5 will cross each other out. If you need to check it on your calculator, that's fine, negative 5 plus 5. And your final answer, 1 plus 5 makes 6. All right, one final question, because it deals with a different operation, I wanted to show it separately. So pause the video if you need to, copy this down, and we're moving forward. All right, the final one I drew in for you, just because this is a little bit different than the adding and subtracting that we've been doing this whole time. This is multiplying. 3 times x equals 9. So notice I have 3 x's on my board and 9 single tiles. Now, the same rules apply. If I can identify this as multiplication, I have to complete the inverse operation to undo it. So I'm going to have to divide on both sides. The way we show dividing in algebra is a couple different ways. You can use your division symbol, but most often you will see just a fraction bar. And this is showing that I'm dividing by 3. How this looks on Algebra Tiles is I would take the Algebra Tiles and I have to make sure that each x matches up exactly with the same amount of tiles. So I'm going to do that this way. I'm going to show that I can split these tiles up evenly 3 different ways, right? And that's really what dividing is all about, splitting them up. When I divide 3 by 3, I get 1. We can write the 1 as a coefficient, but we don't necessarily have to because we know 1x is the same as just writing x. 9 divided by 3, if you notice each algebra tile x matches with just 3 tiles by themselves. So my final answer is x equals 3. Again, pause the video and copy down anything you need, but now your notes are complete. Looking forward to seeing you soon.